Good morning, everyone. Glad that you could make it. Welcome to part of this data engineering process fundamentals series. And thank you for being here with us today. Today's topic is about an introduction to data analysis and visualization. My name is Oscar Garcia. I'm a principal engineer, software engineer. I do a lot of work on data engineering and web engineering projects using cloud technologies. So I'm very happy to share some of my experiences and knowledge with all of you guys. All right, let's get started. So to start with, let's go ahead and ask the question, right? So I'm sure a lot of you deal with data on a daily basis at work. But the question really is, how do we gather insights from data, right? We have a lot of data. How do we really understand what's happening behind, or what is the data really telling us? So to do that, we need to basically leverage the principles of data analysis and visualization. And what does that really mean, right? What is data analysis? But data analysis really just is a process, really, to take a look at the data, analyze it, transform it, and kind of identify trends, data structures, and purpose for that data. And we will take a look at that in more detail. And visualization really is the process to take that data, that information, that knowledge, and really translate that into visuals like charts and graphs that can actually tell a story. So in today's session, we're gonna be talking about this in details by using technologies like Python and Jupyter Notebook. We are going to talk about statistical analysis and business intelligence analysis and compare the two. We will also cover data visualization and talk about the difference between a code-centric visualization project where we actually code everything using Python or any other language that you use. And we're going to compare it to a low code approach where we actually look at an enterprise tool like Looker, Power BI, Tableau, and even Excel for those that use Excel. We have a lot of material here that you can follow. There's a good data engineering project that I work with, and I share that in GitHub. So the link is there below it, and I put that on the chat. If you take a look at the chat, I pasted the link there, so you can follow through. Once we start looking at code, we are going to be looking at that project, so you can actually have an idea of how we are doing this. Okay, so let's go ahead and start talking more about data analysis. Okay, what is data analysis in reality? Data analysis is that practice or process of exploring the data and understanding its meaning, right? It's really where we actually take a look at a data source and we actually start looking at it from the standpoint of the data structure, the data types, what are the fields available to us, right? And the whole purpose is really to kind of identify the dimensions or the categorical fields, right, to be able to understand what the data represents and the measures, which are actually the values of what we need to plot, right? It could be some quantities of sales, refunds, or depending on your industry, it could be those are the numbers. But the idea here is to kind of understand the trends of the data, the distributions, and also understand any kind of outliers that may be making the data not make a lot of sense, right? And we'll talk about outliers in more detail. But the way to accomplish this, it really depending on how you do it in your industry, right? We can accomplish this by looking the data using, for example, Python and libraries like Pandas that are very powerful for creating data frames and analyzing data. We could use SQL, right, and write SQL queries and be able to read the data and make queries and kind of create some kind of data grid with that data. Or some of us can use Jupyter Notebooks. If you're not familiar with Jupyter Notebooks, a very powerful tool to be able to do data analysis, right? It enables you to run Python on cells where you can actually run chunks of code to be able to transform the data, like query the data and understand what's going on with the data. And the benefit of this is that we can use libraries like Plotly and others that are very powerful at creating visuals. So you can actually create charts to be able to understand what the data looks like. This gives you like an analysis way of saying, okay, I think I can represent the data this way. So it is part of this process, right? And obviously the use of low-code tools to enable us to do the EDA, right? Where we actually trying to understand what is it, what is about the data, what do we have, what can we do with it. Part of the data analysis is definitely that same process, that process of data profiling, which what that really means is that, hey, you're telling me that I need to do something with this data. I need to learn it. I need to understand what it does. So I'm going to start looking at it. We are going to identify the data types, dimensions, the measures, and quantity values that enables us to do something with it, right? Like a query, hey, give me the total sales, for example, or give me the total amount of parts for manufacturing something, right? So, so in data types, what that really means is in a lot of these processes, right, we get a data source from maybe from a CSV file, maybe from a database, what have you. But we need to be able to identify what are the categorical data types and or fields and their types, right? So it could be text for categorical, right? So it could be, for example, the station name, department name, anything like that, or even day of the week, right? That's categorical. It could be numeric to be able to understand the quantities, right? The amounts in a daytime value. So this is the process to sort of identify that and be able to define the schema that's going to be associated with this data. Definitely really important, especially for a data warehousing project, right? Moving forward, which is part of this process of data engineering, is that we need to identify the dimensions, right? Which are really the textual or categorical attributes for find the business entities, right? That like I said before, it could be the department name, it could be a region name, it could be any kind of text that describes that group. That enables us to group the data, filter the data, and organize the data in a way that's useful to the business. And definitely measures, right, which are the quantitative values that we can sum and aggregate and select minimum, maximum, and do all those KPIs for organizations to track and understand what's going on with their business. Part of this process as well is data cleaning and pre-process. Data cleaning really means is we don't know what the data looks like, so we need to understand that there could be null values that are going to affect our analysis. There could be bad fields, empty fields, empty rows, or anything like that. So we cannot assume the data is perfect. And what we need to do is we need to go through a data cleaning process, right? And eliminate null values or eliminate anything that is not within the range of an average trend. And what that means is values that, for example, let's say that most of your data points are in the hundreds, but then you come out with one that is in the thousands for whatever the reason. That may be an outlier for some reason, and we need to understand why that's there. And pre-processing really is the process where we actually get the data and we start setting up the data types. We may identify a schema definition, and when we load the data through Python or any other language, we can actually say, well, but when you load it, follow this schema, which is really the columns definitions with their data types. Or we could just go ahead and split columns. Some columns may be together, and you may not want it that way. Maybe they have more meaning by splitting them, right? Or rename, right? So in a lot of cases, we follow certain coding standards, and we want to be able to rename columns with a particular pattern, right? Or standard, where maybe you use underscore to separate words, or make it all lowercase or uppercase. It really depends on what you want to do, but this is part pre-process, and we're actually are transforming the data in a way that will help you, right? And all of these are things that you could do through Python. And all those images you see on the side basically is explaining that how can we cast to the data types, how we can make everything lowercase, and how we can eliminate null values from our data set or data frame in the world of pandas and Python. And part of this pre-processing as well is identifying outliers, right? So outliers are really those data points that are completely off the distribution, right? So we may have very high positive numbers or negative numbers, but they're really not within the range of our values. So we need to identify those because they could be troublesome. They could really send our trends off, and there may be values that are really not true for the everyday or for the average data process that we do. So for this, right, we start getting now into a statistical analysis a little bit, where we actually need to calculate the Z-score, right, which is really just a numeric way or a mathematical way to say that a data point is very far from the medium or from the mean, right, from the average. We have to identify that and use certain algorithms to be able to calculate that, right? Like, for example, setting up a threshold and actually filter out data that is above that threshold. And this is just basic math and basic statistical analysis approach to be able to filter out outliers from our data. Okay, so this takes us into statistical analysis, right? So we started talking about statistical analysis, which is really applying statistical techniques, a lot of mathematical computations, correlation analysis, hypothesis testing, and this kind of stuff. Statistical analysis heavily used in the manufacturing and science industry. And a lot of this also is used heavily for machine learning algorithms. So a lot of these machine learning algorithms that do linear regression algorithms and things of that nature, if you're familiar with machine learning, they use statistical analysis concepts to be able to develop those algorithms. Right. So in this case, for example, and you can see in the code, we are actually looking at something called Pearson correlation coefficient. Right. And what that really is doing is actually evaluating what the correlation is between two categorical values. What that really means is similar to machine learning linear regression algorithm, we are trying to identify if those two fields are really are correlated and contribute to the values that we're looking at. So for example, we're looking at if it is summer, for example, if the weather is, the day is sunny and it's summertime, then that means that's correlation to say that perhaps the sales of ice cream are much higher, right? But if it is rainy, and even though it's summertime, maybe the sales for ice creams are lower, and that makes sense, right? Because a rainy day and the summertime, they correlate in a poor way, meaning they really don't generate sales because it's bad weather altogether. And for that, we use concepts of p-value, which is just a measure to kind of understand the statistical significance of that relationship. And here you can quickly just see on the image, as there is a small correlation analysis being done here, where actually if the p-value is very small, then there is linear correlation. Otherwise, there's no correlation. And this is very important. Statistical analysis is very important because if you want to gravitate, data engineers tend to gravitate towards machine learning algorithms. And that's really what we talk about for machine learning algorithms, right? Typical for statistical analysis, which is manufacturing and scientists, right? They look at this, they look at control charts where they're actually looking the medical industry, manufacturing industry, they're looking at certain data values and say if they are within the control limits, upper bound, lower bound, and they kind of monitor the health or the process or the health of a process, not just the person. And this gives you that kind of control to be able to understand the quality, right? So we have histogram, We have bell curves, and all what they're really looking to do is that they're trying to make sure that the mean of that data is within the control boundaries to be able to understand if the process or the health or the numbers are in control, right? That's a way to measure that a process is within control. And this is a longer conversation about manufacturing and health in scientists, but this is really what you will see commonly in those industries. But let's compare now to business intelligence and reporting, right? So now if we transfer now from a manufacturing standpoint, and now we go into business intelligence, right? That's really I'm sure you heard that term. I'm in the BI team, right? So it's really the approach to analyze data and be able to transform it and actually convert the data into something that has meaning, right? So it's that process to now look at data, group the data, do aggregations, do analysis on that data, and be able to kind of extract information to say, hey, our sales in the north when it's winter time is bad, right? So this is mostly to enable an organization to make informed decisions and to define strategies based on that. So BI is very important, right? So a BI engineer or analyst will actually look at a data distribution based on region, based on weather, based on time of day, understand the data variations based on those categories, and focus on locations, day periods, and actually generate some meaning out of that data. So the business, the CEO of the company, right? Because those guys don't look at tables, they don't look at data, they don't care about that. All they want to do is just look at a snapshot of what the business is doing for the last 3 months, for the last 6 months, for the last 2 quarters, and so on. So they just want to look at a high level view of what's happening with their data. And typical charts that we have for business intelligence really is bar charts, pie charts, donuts, maybe some tables here and there to do some kind of aggregation. But this is really the things that we tend to see in a BI project. All right, so this ties us into that, right? So we are looking at the data, we're doing data analysis. Well, what else, right? What do we do now? We understand the dimensions, the measures. We sort of understand the data. What else do we do with it? So that's where data visualization comes in, right? So data visualization takes that analysis, right, and represents the results of that analysis into a visual format, right? This is more impactful to CEOs because instead of just looking at a bunch of numbers, CEOs just they look at graphs, they look at pie charts, bar charts, and they just look at the numbers or the shapes and colors that they want to look at. For example, green is a good thing, for example, and they may just look at green, while red may be a negative thing. So they would focus on red and say, why is that red? And then you can sort of drill down into what the data is telling you. So this is whenever we go into and do presentations about the data, about the insights of data, it's a good way to do data visualizations as opposed to just doing a bunch of tables with grids and numbers on them. But when it comes to visualization, there are different ways that we can deliver this, right? We can use a code-centric solution, which basically what that involves is heavy coding, right? So we can do a lot of coding using Python, using SQL, and transforming the data frames and doing all the things that we need to do, create our own charts, using Jupyter Notebooks and Python and things of that nature. But there's also, but with code-centric, there are other things to worry about, right? And we are going to touch a little bit more in detail of that. But there's also that low-code solution, right? So a low-code solution now involves more of a design approach, right? As opposed to a coding approach, it's more of a design approach where there are powerful tools like Power BI, Looker, Tableau, that what enables a data analyst is to actually focus on data by just using that tool and not having to worry about whether that person knows coding or not, which is different, right? Skill set, being able to write Python code as opposed to just like designing charts. So when we talked about data visualization with a centric approach, we're really talking about now building out the code from scratch, right? So we have a data source. We connect to that data source. We start writing the code to be able to create categories, convert the data values, create bar charts, create pie charts, and all that. And we tend to generate this charts on a web page, right? So it's an HTML web page that gets generated. So it is great approach for developers that have the ability, the knowledge of Python and the ability to do this. But at the same time, it creates it's a benefit for small teams to share the charts, like developer teams and smaller development teams working together. But it's not a good approach for the enterprise, right? For the enterprise, this is maybe you want a higher quality, you want a faster delivery approach, right? Delivery by, I mean, not just the coding, but actually the deployment activities, right? Because when we start doing development, heavy development, this code needs to go into code repos and it needs to go into deployment cycles, DevOps cycles, and so on. So it's a little slower because of that, right? But when we start talking about a low code approach, right? We are about using tools that enable us to, instead of focusing on the code, we actually focus on the design, right? We focus on the data. So these tools, what they do, they enable us to use different connectors and actually use pre-built components, right? So what that means is we can go ahead and say, I want to create a new chart based on this SQL Server database or this BigQuery data warehouse, and so on, right? Or import all the CSVs from a blob storage or data lake and process them, right? So, and with these tools, you can actually do a lot of the data analysis as well, be able to create views that transform the data with specific data types and so on. So you can do a lot of these activities here. The advantage of this is that the hosting and deployment is really managed by the cloud. So that means it's easier to do deployment cycles, right? Because this is mostly a design and publish approach where you actually just do the design with very low code, snippets of code, or maybe sometimes none, because maybe what you're building is good enough without having to build any snippet of code. And you can then just go ahead and publish, right? And someone can review and someone can say, yes, this is what we need, right? So this is the advantage of low code, and it's definitely something you want to do for the enterprise solution, meaning for when you need to present this to the executives, to management, to the entire enterprise, is a higher quality enterprise solution, more security, and so on. All right, so this will be the closing on the presentation. We'll come back to final thoughts, but let's start looking at some of the code. Okay, let's switch to that. So if you follow this link that is there, you can actually load this project here. And let me blow it up a little bit. Right, so this is a data engineering project. It goes more than just data analysis and visualization. It actually looks at other aspects, data engineering process, discovery process, building out data pipelines, building out cloud infrastructure, and all that. So you're more than welcome to follow this. Give it a star if you like it. And as this continues to be built with data streaming and other concepts. But we want to take a look at here once you have this code, and we'll open Visual Studio as well, Studio Code, to do this. But I want to navigate through the project a little bit so you can see it. The areas you want to take a look at, for example, of what we're talking about when it comes to data analysis and using Python, so you can get some concept of what we're trying to do here, right? So there will be a problem statement of what we're trying to achieve, so we can, at the end of the day, we can build out a data visualization like this, right? So we won't get into details of the entire data analysis because the focus today is really how do I use Python, how do I do data analysis, how do I do visualizations. But just understand this gives you the background of what this data source is. But in reality, what we're trying to do here is kind of identify from the New York subway system trends that can enable businesses to do advertisement targeting, right? So they can target individuals based on the geolocation, right? So, but usually what we do is to be able to do this kind of projects, we start doing data analysis, right? So we start with the discovery process, and during the discovery process, right, you want to look at files that are IPYNB, which is an interactive Python notebook, right? And what this is, if you're not familiar with Jupyter Notebooks, in reality, they enable you to write snippets of code and run those cells, right? So for example, quickly, just to browse through quickly here, here we actually do analysis of data, a CSV file, right? So we're saying we're importing all of the libraries that we need. We import pandas and some of the time libraries to be able to do data transformation. We do here is we start reading some of the data roads, and we say, look, let me check the null values. Let me take a look at some of this data and fill out null values. So we start doing sort of some of the cleaning process of the data and the data analysis, right? One thing that's very powerful and important is once you load that data frame, you want to be able to say, hey, what does this data have? What are the fields? What are the data types? And you start looking at that, right? You start seeing that it has these different columns, and then you start thinking about what do they mean? What does unit, SCP, station, right? Some of them are kind of clear to understand, all others are not. But the thing is that you will notice that there's some types that are integers and some types that are objects, and usually objects will be strings, right? So you know by default that some string types are categorical features, meaning those are data fields that where you can group by nation, you can group by division, right? And you will notice that the day and time fields are separated. And based on your requirements, you may not want to do that. Maybe you want to be able to join those two fields together. So this is kind of the exploratory and discovery process, right? To be able to understand the data using Python or whatever other language you have. The idea is to be able to do the approach, the analysis. So for example, here I'm just kind of showcasing that with Python, we can come in and say, I don't like this day and time field, doesn't make sense for us. Let's go ahead and join them, right? Then quickly you can use pandas and transform this, right? Say, look, join the day and time and give me another column called created. And now I want to look at my data that way. And you can easily start doing this pre-processing, right? This is part of the pre-processing concept. And you start making observations, right? We gotta start understanding, and we gotta file that data and kind of say, what are these entries and exits and stations? Are this what we're looking? What are we looking to do? And if you read the background and problem statements, in reality, what we're trying to do here is we're trying to say we want to know the number of commuters at a certain stations so we can target them. So the goal will be is based on that station, that business near that station would probably want to know when people are entering and exiting the station so they can target them, right? Through their phones, right? So here we can actually start with that, and we can actually start simple doing aggregations, the group by, right? I want to be able to group by station and that they created, and want to be able to look at the number of entries and exits. And you start looking at those numbers, and this starts giving you an idea of what is happening, right? So, but here, the focus here is the process, right? The process, how do we do it? Why do we do it? And how we can use Python, Jupyter Notebooks, Visual Studio Code. By the way, this is done in Visual Studio Code, and I'll show you that. And I'll show you a live session on how that works. But then you continue to do that, right? Now you want to say, no, I don't want to group by date. Let me just group by station because I want to maybe just be able to identify the aggregates. by station, because that may be some of the requirements for you. And this is how you will do it, right? You will use a data frame and say group by a station, give me station totals, and let me just display the first 10, because we're going to have more stations. They have like 80 stations, right, in the subway system. And we want to do additional analysis. We want to look at the total entries by station, only using a subset of data, right? It's just a small subset of data, because we want to be able to kind of start looking at this a little bit more, and maybe looking at the data by day of the week, so we start looking at, how do I do that? How do I transform it? Because all I have is a date and a time value. So, but I would like to map it by, is it Sunday, Monday, Tuesday, right? And then you can do that through code, and you can do that through a low-code tool that enables you to do data mapping, even if it requires you to do a little bit of a snippet of coding, and I'll show you that. But the point is that this is the process, right? This is pre-processing the data. You kind of pre-processing the data, identifying new dimensions. This process right here, what it just did is identify a new dimension, right? Because the dimension is, we only have a date. Now we want to do a weekday, right? We want to have a weekday. That's a new dimension that we're creating off of a dimension that was available for us, but it was not on the format we needed. And that's the way to think about this for data analysis. And then you are able to do your charts and your analysis and do that. So that's part of sort of the discovery process, right? And that's pre-building. That's the process that is to identify how you do your data. What does the data tell you? How do you clean it? How do you pre-process it? But it's not the end of it, right? Because this is going to go through an entire data pipeline where you're actually going to process this data and sort of do this. But then now you got to go now into a true data analysis for the sense of the business. How do we do this for the business? What do we need to build, right? Pie charts, bar charts. What are we looking at? So that's where you go into analysis, step 5, right? Step 5, then you will have a series of Jupyter Notebooks to sort of do this analysis based on what you want, based on what you're looking for. So let's take a look at analysis, right? Looking at analysis, the same approach is another Jupyter Notebook. But now think of this one instead of the front end, think of this on the back end of the process. So I mean front end and back end of the process. So the process is in the front end of the process, we're looking at, hey, we need to do this, and we have this sample CSV to kind of understand what the data looks like. In the back end of the process, we're saying, hey, look, we went through the entire pipeline. We have a live data pipeline that is getting this data on a daily basis, a daily feed, it's processing it, it's transforming it, and it's dumping this data into a data warehouse. Let's take a look at some of this data and kind of start understanding, how does it look now that we're in a data warehouse? Because the data warehouse is probably going to have joins, right? It's going to have SQL joins and things of that nature. And you can look at the data warehouse, data modeling process, where I cover that more in detail. And I'll be doing more presentations on that as well. But here the idea is that this is on the back end now. So we're now looking at, okay, what is this telling us, right? So we have a station name, we have the entries and exits, similar, but look at it now. So now we have a standards, we have lowercase names, right? We're using underscore to separate words. We're using lowercase for all of our fields, because that's really our that's our standard. So that's what we're following. And we start looking at this, right? We start looking at some of the describing the data, because maybe we want to do some kind of analysis when it comes to outliers. So we're looking at the counts of records, standard deviation, the mean, things that are more for statistical analysis, right? But you can actually look at this data. This data may not mean a lot to some people, because maybe they're not familiar with this, but to a lot of people, this means a lot when they start looking at statistical analysis. You still need to do your data cleaning and pre-processing, because you don't know in the back end if the 100% through the data warehouse. You still need to account for the fact that you need to cast it, use your schema. You need to make sure that all these things are in place. You need to do data analysis and get some of the outliers, right? Do that same thing that we talked about. Get the C-score. of that data, do a track of 3, and kind of see if there are outliers and prints. So for example, here we're looking at some outliers, and we've actually found some outliers for First Avenue, for 101st Street, World Trade Center, right? So we started looking some outliers, but and what does that mean? Is that outlier something valid or invalid? And going into that thinking process, is it valid or is it invalid? Because, for example, there may be a lot more traffic for entries for certain stations and a lot more exits for other stations. So it's looking at that correlation and see. So, and we have to look at it. So what this is actually doing is looking at this from the standpoint of a subset of data. But the question is, what if we start doing a lot more data, and is the correlation valid or invalid? So it's the process, right? We continue that process. Look at numeric trends, right? We inspect distributions of arrival, departures, time slot, the same things we sort of show morning, find outliers for arrivals. We do that analysis, right? And try to see if we can actually find things that are off, right? And do some hypothesis testing to make sure that data is accurate. Here we that there is a big correlation. Once if there is the correlation is not valid when we use a subset of stations, like 10 stations, but once we use the entire population, the p-value is 0. What that means is that definitely there are some entries in some stations that are higher, but when it comes to exits, there's a lot higher exits, which balances the information, right? So some people are getting off from some certain locations and getting on in some other locations, which is expected on a subway system. But this is important to understand that process and the meaning of it. Right, in business intelligence, show the total entries by station using a subset of data. And what's important here is the analysis, right? How do we do this? How do we start reading this, right? So when it comes to the actual code, the way that works, right? So this is Visual Studio. You can clone that repo. You can actually run it live. And the way this really works is that when you hit a cell here, I hope you can notice it. You can just do Control Enter, and that cell will be executed using a Python 3.8 kernel. So you will click on that Python 3.8 kernel and run that cell, and then you'll be able to run every cell sequentially, right? So this is like, think of when you code, you sequentially run this, and you're able to see define data frames and define certain values so you can use them on the other cell. So here we're just doing a data frame info, just like we saw on and we can see, right? We can see the data types, and we can do all these transformations here, the same thing. So Jupyter Notebook is excellent for kind of data analysis and prototyping, where you can actually just write that chunk of code and run it, right? And quickly run it like this. So it's very, very powerful to do that. So, and we also have other. So that's the discovery, right? So here we have, this is the analysis one that we talked about, right? So where we read the file and display a few rows, and we describe it, and we do the data cleaning and pre-processing. So this is in the backend analysis that we're doing this, right? And you can just run this, like I said, sequentially, and start looking at this, right? We also have, example, the statistical analysis charts that you noticed there. We can actually go and look at the manufacturing document. And in this manufacturing Jupyter notebook, I should say, not document, same thing. Make sure the kernel is loaded, otherwise this won't run. And you can define your functions, right? For example, create control chart, right? And define them, and then you can then run the whole thing. Here, create control charts, create box plot, create histograms, and chart them like this, right? And very powerful way to do quick analysis, understand your data, get an idea how this works, right? And also, of course, you can do it through code. You can do it through, once you have that data, you have APIs. You can do it through JavaScript. I use Plotly a lot. I do it through JavaScript. You also can do it through Python's a lot of coding as well for be able to do web development, but I prefer to use JavaScript for that. I believe Python is mostly for this kind of analysis, machine learning and data engineering analysis, but when building websites or web applications, I think definitely. But this will be an example that you can take a look. Builds a web page that has a bunch of charts and a dashboard, and you can browse that. Uh, uh, after the presentation, you're more than welcome to clone this and give it a start and just take a look. And there's a lot of material here to continue to learn. But as we saw, Python's very powerful. We can do a lot of coding. As you can see, there's tons of coding here that we can do just to kind of build this out and do correlation analysis and do all these things. But when it comes to a low-code tooling, all right, low-code tooling, now we can start looking at other powerful tools like let's take a look at this dashboard. This is a live dashboard, which is now this is the final delivery of that analysis, right? So now as a business, you can come in and target certain stations and look at the trends, right? Look at what's happening here. What are your numbers for that particular day? What are your numbers for between 12 a.m. and 4 a.m.? And kind of look at that analysis and see how to target your customers, right? Based on that geolocation. But the powerful thing about this is that when you edit this chart, so I'm going to edit this on live. This is a live edit, right? What you will see is that this has two data sources connected, right? It has this data, if you can see it. I'm going to try to blow it up a little bit, right? This data source here, and it has all the dimensions and things that you can use, right? So the way this works really is that what you can manage and connect to data sources and tap into a data warehouse. In this case, we're connecting to BigQuery data warehouse or SQL Server or SQLite, what have you. But the idea is once you connect to the data source, you will see the tables that are available, and then you can actually read the fields that are available. So for example, here, if we wanted to do the pie chart here, right, the donut chart, then what we do is we say, hey, we connect to this data source. We want to use the created day dimension for our slicing the data within a particular time range. Use the station name as a dimension to be able to look at the names and then look at the values, right? Look at the trends and the distributions for that. If you want to do something more complex, like for example here that we have bar charts and we have in between some time slots that are not well defined, we need to create our own dimensions that will give us that. So usually what will happen there, we create a dimension here that's calculated through a little bit of code. And you will see that what we do is we're saying, right, let's take a look at the created day. And when the time is between 0 and 3, then that's my time slot of 12 to 3 to almost 4 a.m. Right. And this is the snippet of code. That's why this is low code, because if it's something special you need to do, this is how you will do it. This is how you will be able to create. So a lot powerful. Power BI, Tableau, beautiful, powerful tools. But going on, it's a lot of materials. More than welcome. Go ahead and visit that GitHub project, clone it, please. But the final thoughts really is that data analysis visualizations are very important, right? Just the process of it all is important. Be able to do that, right? Be able to understand what the data tells you, how it looks like, and be able to actually communicate the insights through visualizations is very important, especially when you're dealing with executives, right? CEOs, very important, right? Don't ever just give them a spreadsheet, right? Don't print out a spreadsheet and give them that. That doesn't look good. So, and what approach to take if you want a code-centric, low code, it really depends on your team, your expertise, and your budget, right? Because once you start getting an enterprise solution, definitely you're going to have to pay for that service. But it's worth that cost is worth it if your development cost is a lot higher. So you need to evaluate that. So please take a look at this screenshot. I'll send these materials post the presentation. Look at these resources, copy this. Definitely, I have a blog about this a lot, so you can look at my blog as well and read about it. I'll put it on the chat really quick. But definitely coming soon if you want to follow up. Machine learning talks, how to host your machine learning models and build APIs using cloud technologies, a lot of AI engineering with LLM, and also a lot of data engineering with web development concepts. So, but this takes us to the end of the presentation, guys. Thank you. Thank you so much for participating, being here. I'm happy that you guys can make it. And please do a follow-up. Connect to that GitHub project, please. Continue to follow a lot more presentations, more information there. And I definitely thank you. And I'll send you, wait for that the emails that come out. I'll put this video on YouTube as well, so you guys can take a look after and share with your friends. And thank you so much. You guys have a great day. Okay. Bye-bye.